All right, so any ideas what an inequality is and what it's got to do with what we have been doing? Yeah.
Inequality is when two different expressions are not equal to each other.
It could be true, but it's not what I would call a definition of inequality. Yeah, we're not going to spend a topic on all the things that don't equal each other. Okay? But we're kind of moving in sort of that direction, quite a way off, but sort of. Any other ideas about inequalities? You get the idea. I like what you said. The inequality is mean basically could suggest the not equal to. Yeah. It's not quite not equal to. Do you know what an equality is? Say again? Things that are equal to each other. What do we have as examples of where we can say something equals something that we've recently worked on? Yeah? Give me an example. Just give me an example, whatever you think.
Y equals 2x plus 6.
Right, hang on. Y equals 2x plus 6. Before you go any further, is that not an equality? We don't call it an equality, we call it an equation. Which is, if we have an if I just put an L rather than a T, all right, we are saying one side is equal to the other, yeah? So if I take 2x plus 6, if I take a value for x, I multiply it by 2, okay? Then I add 6, I get a number, and I'm going to call that number y. Okay, yeah.
Is inequalities also with greater than or less than?
Yeah.
Rather than just like
Yeah. So with this one, basically, how many values can I choose for x where I will then get a value that will equal the y?
No. Oh, infinite, because it's 1.
Goes to 6. Every time I go across 1, I go up
3.
2. So 0 with 6, 1 with 8, 2 with 10, and so on, yeah? What are all these things in between those points? Other points, yeah? That match with 1.2. 1.2 would match with
8.2.
1.2 multiplied by 2 is 2.4 plus 6, 8.4, isn't it? Okay? They match up. So, how many times can I find values where the x multiplied by 2 plus 6 is equal to something else? An infinite number of times. Okay? And this line represents all of those particular values. But that line also separates the space into two regions, which is, well, this region up here, call it region 1, and under here is region 2. How would you describe region 1, region 2, using our x's and our y's? Take a moment to think. Okay, Liam?
Is it 2 times
Which one?
R1
Okay.
plus 6 is R2?
Nope. Cameron?
Anything so the R1, anything above a value of 2x plus 6.
So how would you describe it using the y's and the... Because is there a coordinate up here? So give me a coordinate that's in this region. Any coordinate you like.
10 and
Why'd you enter 10? That's not on. I've got some nice ones. I picked some coordinates for you to make this next step easier. 1 and 10. So 1 and 10 would be here, yeah? 1 and 10. What do I know about 1 and 10? Which values are they? 1 is the
X and 1 is the Y.
well, 1 is the x,
And 10 is
10 is the y. So let's just have a look at that, all right? And what that means. So the line is where the x value doing this equals the y. But if we look at 1 and 10, well, if we put 1 in and we multiply it by 2 and then add 6, what comes out? 8. Yeah?
So R1 is y greater than 2x plus 6.
Is that what you're going to say, Steph?
Yeah.
I figured that out as soon as I was like, oh wait, I understand now. And then it was 1
Yeah.
is less than.
Exactly. So in this region, region 1, we can say that the y coordinate, because this region is how many coordinates?
Infinite.
Infinite. How many coordinates on the line?
Infinite.
How many coordinates under the line?
Infinite.
Okay, it's good that we've got 3 lots of infinite. Alright? Which infinite's bigger? So in this region, region 1, we can say that the y coordinate is actually larger than if I did 2x plus 6. In this region, we've got y coordinate will be less than if I did 2x plus 6. Okay? The line is when y is equal to 2x plus 6. Okay? How many coordinates satisfy what we call this inequality? An infinite number, yeah? Alright? So, the difference we've got then, so an inequality is where we don't have a specific point, we might have lots of different points. So an inequality is when we have this, it can be greater than or it can be less than. Alright? We can include the have equal to as well. Alright? But on a graph we've got these regions. The line itself separates the regions. So let's just have a look then. Alright? About a situation. So we've been looking at equations such as 5x plus 4 is equal to 24. Yeah? I could write an inequality, which would be, well, what about where 5x plus 4 is greater than 24? Or we could do where 5x plus 4 is less than 24. Okay, by the way, why, thinking about yesterday's lesson, why would I be interested in inequalities? Yeah?
Because last lesson we were finding the break-even point, but then, like, if it's unequal, then we can't. This is like what would happen if we couldn't find the break-even point. It would be inequality.
No, it's not about can't do it. I can do it. We did do these, but I'm asking not whether I can or can't. I'm asking why am I interested in the inequality? Steph?
Is it related to the fact that parallel lines don't have a solution?
It's not even that really. No, it's just take it basic single line. Why do I want to know why 5x plus 4 equals 24? So in this case, it could just be, well, that's the point at which I'm going to start making money, right? Why would I want to know where 5x plus 4 is greater than 24? Because that's all the area where I'm going to be making money, yeah? So if you think of an inequality, actually, a break-even point is the precise time, but actually, after that, I'm still going to make money, right?
Yeah.
So I would actually express this as an inequality where if I break even on week 6, when am I in profit? Week 6 and after. So greater than week 6, we could say, yeah? So we're not limiting ourselves to one value. We're saying, right, when will I be in profit? Well, from week 6 onwards, yeah? And I need some way of saying that. So for instance, we could solve this. What is the value for x when this equals 24? X has to equal 5. But when is 5x plus 4 greater than 24? When x is
Then 24.
greater than 5.
Isn't it 4?
It's not 5.
Okay. And what about this? The last one is x has to be less than. And we should always do a check, which is, well, how do I check that x equals 4 is correct? Substitute it in, yeah? So we do 5 multiplied by 4 plus 4 is equal to 24. Okay, good. I'm happy. How do I check an inequality?
Oh, yeah.
Okay, go on then. I'm going to check with x equals 0, 0. X equals 5 would be greater than 4, yeah. So I put that in and say, right, in this case, when x equals 5, I want 5 times 5 plus 4 to be greater than 24. So we've got 29 is greater than 24. Tick, I'm happy. Yeah. Same one. So check with x equals 2. In this case will work, right? So I do 5 times 2 plus 4 should be less than 24. So that is 14 should be less than 24. Tick, I'm happy. Okay. So what do we know about the process for solving an inequality? I kind of alluded to without actually doing it. How do you solve an inequality? Liam?
Would it be for break even to find your break even?
Well, let's not focus about break even at the moment. Just any inequality like I've just put on the board. How do you do it? Is it something new that I've got to talk you through?
It's you have to like get what your x or y value is equal to, and then like make it so the x's and y values
Yeah.
are true. Make it so it's true.
What were you going to say, Ryan? Well, I don't have a y. What I'm saying is here, how did we solve this one? I didn't substitute, I just solved it, I just did equivalent forms, didn't I? And then, I think like Liam was mentioning, if I solve for where it's equal, because we have that method, don't we? It's easy, right? Make sense? So if I said to you now, right, solve where 2x plus 3 is less than 5x minus 6. Now on a graph, what does that look like? 2x plus 3 kind of goes up like that, yeah? Crosses at 3. 5x minus 6 goes minus 6 but goes up steeper, right? So where is 5x minus 6 greater than? Cameron? So find that because that's where they are equal. So after this point here, so this section onwards, we can say that this side is
True.
greater. Yeah? So now I just need to find that point. How do you find it? Well, should we just ignore this and call it equal? Because that's what you want to find first, yeah? 2x plus 3 equals 5x minus 6. What do you do first? Yeah? Subtract 2x, okay? So if I subtract 2x from there and from there, I get
3 equals
3 equals 3x minus 6. And then add 6.
add 6 gives me
9
9
equals 3x.
equals 3x.
And then the red one.
I was not expecting it to be this nice and number. You know, didn't even think. So this is now x equals
3.
3. Alright, so that means that x equals 3 at that point. So what's the final solution? Is not the equals, it's the, put this back in, right? Make sense? So actually we don't have any new maths. You do all the procedures that you've been doing before to solve all your equations. The only bit to consider is about the symbol. Alright? There's no kind of, well, at the moment there's no special kind of appreciation of what we have to do with that symbol. We just consider it maybe at the end. Yes?
Also, yes, we have to be careful with the opposite side so you can represent it easier because cosine is simplified with that. Like, v is greater, v is less than x, we switch the side so it's x. Like, what would
Oh yeah, so this, I guess this is what I was saying about don't get used to having the x on the left-hand side all the time. Right? Because if I did just write out x, I'm going to put x on this side and kept the symbol. Now it's wrong, right? So be happy. Now, there is, and I'm not going to tell you why, but there is a time where I can do all this perfectly correctly and my answer will be wrong. How again do I check if this answer is correct? Right? Substitute. What would we pick for this one?
Oh.
Definitely don't pick the one that you've just worked out.
4.
Pick 4, right? I also say, guys, you don't have to pick a value that's close to it, right? Assuming that the maths is right, the only thing we're really checking is whether my sign is the right way round at the end.
Well, sometimes you have to switch it and
Sometimes, right, and you'll see this in the textbook, so I'll get you to do some questions. I never have taught it like this. I think what we do is we go through it, we just plonk the sign in as it is at the end, and then we do a check. And if I check with x equals 4, and I get a, oh no, that's wrong. Alright, it's not working. This is not less than that. Let's say it did. It's not going to in this case. But let's say it did. First check is to check my maths. So for those of you that don't like writing all your steps out, how are you going to do that? Alright, so check my maths. If I'm happy with all my steps, which you guys will be because you're good at this stuff, my next step is, well, if x equaling 4 is giving me the wrong way round, if 2x plus 3 is actually greater than 5x minus 6, maybe my sign needs to be the other way round. And I would check with x equaling 2 and see whether that's right. And if that's right, I just swap my sign around. Now there is a reason, there is a process that you will do that if you get to that stage of your understanding, you'll go, ah, if I do this, I know I'm going to have to swap the sign around. Alright? The reason why I don't discuss that and make a big thing of it is because that can confuse people, because that's what they're trying to remember, that little tip or trick. They go, oh, when do I swap the sign? When do I do it? It's like moving and swapping signs. Right? It always leads to confusion and problems. So I would say go through your process and get in the habit of checking your answer. Because you might end up doing two things that cancel each other out and flipping the sign, and you should have done it twice, and you only did it once. So that's why I say check your answer at the end. Cameron?
How would you represent it not, like X not working as 4 on the graph? Because the sign.
An unhappy face, surely, no?
Like, in this scenario, it's like, oh yeah, anything above this would work. And then if it doesn't work, then that line wouldn't continue here, or it would be in a different location. So like, see how 5x minus 6, that we're talking about.
Yeah.
How would that be represented if it doesn't, x doesn't?
Okay, so basically what I'm saying is I want to know which values of x make this true. So that basically saying from this point, all right, from that point, I only want the line going up, which means from this x, which x values am I allowed? I'm allowed in this direction, yeah? Because the line carries on. I'm allowed how many of these points? All of them, yeah? All right? If, however, I said x is, let's say I was supposed to have this side, I'm actually just going the wrong way, yeah? Now what you might be considering is, what if we're not dealing with linear anymore? So what if I said to you, where is x squared less than, I'm going to chuck this one in because that's what I want to do next, less than 2x plus 5. Now how would that look on a graph?
Is it parallel?
So the 2x plus 5 can look like that, yeah? Happy with that? 2x plus 5. A quadratic, x squared, do you remember?
Parallel.
It's a curve like this, right? I was getting one. Right. Where is 2x plus 5 greater than x squared? Liam.
Past the part on the right.
Here?
Yes.
No. Owen?
Oh wait, no, sorry.
So we're going along here. This is where 2x plus 5 is under, so less than. So we hit this point and we get the and equal to, yeah? That's that line. The second line is and equal to. That means I'm allowed this point here. And then, as Owen was saying, everything from here until we stop here. Why? This is where the white, this line is now under it again, yeah? So this bit here, this red bit, is above the curve only between these 2 points, right? Sorry, that's not so clear. Right? Only between those 2 values. So how would I write the inequality solutions to that? Well, let's try and solve x squared equals 2x plus 5.
Would that two answers?
Get 2 answers, wouldn't it? Do you know how you would do that? No. Well, this is where we will get to eventually. We have to solve a quadratic. We would do x squared subtract 2x subtract 5 is equal to 0. Okay? That would be one way. We can do that using a formula, or we can try and factorise. We need to get to that stage. You don't worry about that at the moment, but we are going to end up with, like say, when we solve a quadratic, we're going to end up with 2 values where x is going to be less than or equal to b, and then greater than or equal to a, right? So that will be, so you can see where inequalities go to. But to start with, when we have just two linears, why are we only ever going to have our single limit? Exactly, they only cross at one point. All right. So, just to summarize again then, so you're finding the point where they are equal to find your reference point. You do that. This sign can then be put back in. Check that you're going the right way. So again, how would I change things if I had an and equal? And equal to 3, yeah? Now, just in case they ask you, there is another way to represent this step, isn't it? Just bringing you back to the room. All right? Another way to represent an inequality, so that's the good way, yeah? That's what we're all happy with. But another way, they might say do it on a number line. And to do it on a number line, basically you put a line. I put my 3, okay? And it depends on this symbol. If it's the not equal to, I put an open circle, and I put an arrow in the direction of values that I'm allowed, like this one. If it's allowed the 3, I fill in the circle to say I'm allowed the 3 as well. Okay? So that's when it says represented on a number line as well. All right, so you, textbook, this is M1. Okay? So in the textbook, what you've got is, to start with, oh, blimey, that chair was a bit low. You've got all these little rules about inequalities. All right? If A is greater than B, then A subtract B is great. Basic number work. So you can go through. So we're looking at topic 14.3, page 557. So on from that point. Okay, it gives you some little rules. You can go through them and you can write them down if you feel you need to. But what we're then doing is, also, this is the point at which they start saying, oh, did the signs switch or not? Up to you if you want to go through that. But really, practice 1, have a go at solving those inequalities and see what happens. Again, I can't insist. I would strongly recommend with inequalities you always do that check at the end, your final. And I will hope, if I see an assessment, for instance, that I see a check with a yes, I'm right or wrong at the end. Okay? Make sense? So this is what you're doing. So page 560 is practice 1. Have a go with those. See which ones you have to change the signs and which ones you don't. Maybe you can then make your own conclusion as whether there's a rule that you can follow. All good? Okay.